today we are going to talk about COMP 207 Database Development Lecture 6 Transaction Management Conflict Serializability using 2PL. So the definition for the 2PL is that we is going to introduce as follows. So firstly, let's review something that the all schedules can also be called concurrent schedules, and if that schedule can be, it has an equivalent. I mean, the equivalent here means the effects are equivalent, which means that maybe that concurrent database maybe end up x equals to 1 plus n, and that there is a serial schedule which can also make x equals to 1 plus n, and that means in no matter what are the initial state, for every initial state, it will have the same effects on the final result. So it will, so what if that concurrent schedule can have that kind of property? It will become a serializable schedule, and so that is serializable schedule. And then, what if it is the conflict serializable schedule? However, the key issue is that the serializable issue is very hard to determine whether it is serializable or not. Therefore, we need because it has related with some maybe non-database operations, and then it comes to the, in order to make our life easier, we will going to introduce the conflict serializable schedule, which is much more easier for us to identify. So firstly, what is conflict? The conflict is so this is just the schedule types, the ordering of all operations in the transactions. The schedule is the ordering of all operations in the transactions, and here we can have build an overview that this is transaction 1, this is transaction 2, and this combined together it is called the schedule, and the operations the transaction consists of many operations. This is a higher overview. So the serial schedule is that the first one entire transaction and then the second one. So first, for example, this is the transaction 1, this is transaction 2, and the concurrent schedule only requires operations in each transaction. Only requires the operations in each transaction appears to appear in the same order. So the concurrent schedule only requires operations in each transaction appears to be in the same order. Only requires operation in each transaction appears to appear in the same order. So this one is not very intuitive. So only requires operation in each transaction that appears to in the same order. So for example, only appears to appear in the, I'm not very sure about what are these maybe appears to appear in the same order mean. And the serializable schedule is the effects on the database is the same as some serial schedule, and it's very hard to check. Therefore, we introduce a conflict serializable. So firstly, the conflict serializable has some characterizations. Has some characterizations that it must it must is a conflict in a schedule. A conflict in a schedule is a pair of operations from different transactions such that the operations access the same item and at least one of them is the right operation. So, for example, that the key thing that you cannot swap them. I mean, you cannot swap them because that will the key this is how can we define a conflict that two is a pair of operations where there must be one right and it must be in different transactions and with the same variable. However, the key thing is that you cannot swap them. If you swap them, you will reach different things before or after the write. Okay, so we are going to talk about the conflict serializability. So what if the two schedules from S and S prime are conflict equivalent if S prime can be obtained from S by swapping any number of consecutive? So the key takeaway is that S prime can be obtained from by swapping any number of consecutive non-conflicting operations from different transactions. So for example, so how can we identify so if we want to conflict equivalent is just exchange consecutive and non-conflicting operation to make a serial schedule. So these two are conflict equivalent. So a schedule is conflict equivalent. It is a schedule is conflict equivalent if it is conflict equivalent to a serial schedule. A schedule is conflict serializable if a conflict equivalent. A schedule is conflict serializable if it is conflict equivalent to I see. So here we introduce the definition for the conflict equivalent. So what if after you do all maybe swapping the consecutive and non-conflicting operations to the schedule S, and finally you get an serial schedule, and then you get an conflict serializable. Oh, cool. So just change the equivalent to serial schedule. Okay, that's very interesting. And then we come to the precedence graph. The precedence graph for a schedule S is defined as follows. First, it is a directed graph. And the nodes are transactions that occur in the transaction. It has an edge from transaction Ti to transaction Tj if there is a conflicting pair of operations OP1 and OP2 such that OP1 appears before OP2. Just like and OP1 begins in T1, OP2 begins in T2. For example, let me show you why the precedence graph is as follows. So the first thing we need to do is identify how many transactions we have. Okay, we have 3. Okay, here is T1, T2, T3. Okay, and then look at some conflicts. So let's look at X first and right. Okay, I found the right X. And look at another. Okay, I found since it is not different transactions, and we will look at another X. So this one is different transaction, right? And we found this is an conflict because this is the same variable, different transaction, and at least one is right. And then we look at maybe I found another X. We found another X that it is the same variable and different transactions, and that both of them are right. I mean, at least right. And then we are going to talk whether this is oh no, this is not okay. So x we have done. Let's look at y. So oh yeah. I think this is also right because x here is x and the r2x w3x yeah. So look at x. Okay, let's look at y. So in terms of the y, we use a different color. We have maybe this color. In terms of y, let's look at the right y. Okay, there's two right y. This is right one. So I think these two are a conflict. Okay, and this W1y and W, yeah, these two are conflicts, right? Yeah. And these two are conflicts, right? Yeah. Okay. So far as I'm concerned, and we are going to write some precedence graph. So this one is going to. So this is the first one. Okay, this is done, and W1y, W1, and R2 and R3. Okay. Okay, and look at the W1y and W2 R2y. Let's see, R2y and W. So firstly, the y operation, W1 to W2, right? This is W1 to W2. However, it has an W1 to W2. So I'm not very sure. So it has an edge from transaction Ti to Tj if there is a conflicting pair of operation. If there is a conflicting pair of operation OP1 and OP2 in S such that OP1 appears before. Oh, I see. Oh, before. Oh, it's a schedule. Okay. So it must be T1 to T2. Oh, it must be T1 to T2. So T1 to T2. Oh, T2 to T3. T2 to T3. T2 to T3. And this is T1 to T2. And this is T2 to T1. Okay, I see. This one is T2 to T1. This one is T2 to T1. This one is T2 to T1. So this becomes problematic. And this one is T1 to T2. And then we found a cycle here. So, it is not serializable. Okay, cool, interesting. And to test whether it is the schedule is conflict serializable, we construct the preceding graph, and if the preceding graph is acyclic without a directed graph, and then let's look at this one. Okay, let's do the example for this one. So how many transactions do we have? 1, 2, 1, 2. Okay, 2 transactions. T1, T2. Then we look at how many conflicts do we have. So look at we have 2 variables, right? We have 2 variables. look at the maybe wx and wy. Okay, let's look at wx. So we have w1x, w2x, w1y, and w2y. Okay, let's see. W1x is going to be conflict with the R2x. It's going to be with R2x, and it's also going to be conflict with W2x, and then we are going to see that so this is all y and this is all x, right? So W2x is going to be conflict with W1x, right? It's going to be conflict with W1x. It's going to be yeah, right. And let's look at the y variable. So this one conflicts with R2y, and this one is conflict with this one, and R2y is going to be conflict with just the same. So the third operation is that we are going to there's an edge from Ti to Tj if there is a conflict from operation 1. Okay, so let's see. 1 2. Okay, 1 2 2. 1 2. Okay, 1 2 2. So this all is 1 2 2, and this is 1 2 1 2 1 2 1 2. Yeah, that's great. It is direct the same. And then let's going to talk about the example 2. Okay, example 2. Let's talk about example 2. Let's think about example 2. So I think it is the same actually. R2x, W2y, W3x. It is the same with that one. So that one is the same with the preceding one. It is the same with the one above. So let's continue talking about maybe. So the example, I want to verify whether it is conflict serializable. So let's do that. I think this one is different, right? This one is different. Yes, let's do that. Okay. So how many transactions do we have? 1, 2, 3. Okay, 3 transactions. T1, T2, T3. Okay, let's look at the okay, all right operations. That's brilliant. And and let's look at if it has a cycle. Okay, so let's see. Okay, let's look at some transaction. Okay, this transaction 2, 1. Okay, 2, 3, 1, 3, and yeah. Okay, and this is 2 1, 2 2 1. 2 3, 2 2 3. 1 2, 1 2, 1 2. 1 1 2 and 1 3. So this is the same, right? So this is just good. So let's continue doing the verify whether the schedule is conflict serializable using preceding graph. So let's do that. Okay, this one has more variables. Okay, so let's see. So this is 1 2 3. 1 2 3. There are going to be 3 transactions. Okay, T1, T2, T3, and let's look at some right. Okay, this one is right, and this one is right, and this one is right. So this one is with relation with x. So let's look at other x variable, and x variable. So this one can only be conflicting with x. So this is sorry. So this is not conflicting with. It's conflicting with that. Okay, and let's look at there's no x related here. Okay, no x, cool. So let's talk about y. So y, we only have this one, and look at other y. So this is w1y and r3y. Okay, so these two are equivalent, w1y and r3y. So no, yes, this is no other y. Okay, cool. So and r2z, let's talk about r2z. Okay, and z we have w3z. Okay, so the w3z we have, so look at all the transactions with related to z. So we have w3z. So this is so r3z, no problem, and r1z, that's a problem, and r2z, that's also a problem. W3z, R1z, R2z. Okay, so let's talk about 3 to 1, and 1 to 2, 3 to 1, 3 to 1, the same, right? 3 to 1, and 3 to 2, Yeah. So I think this one is the this one is the I think that this one is whether it has a cycle. I don't think so. Actually, it does not have a cycle, and yeah, it has no cycle. It's the same, and it has no cycle. It is conflict serializable. So can you find the conflict equivalent schedule using the conflict equivalent schedule using your preceding graph? Okay, that's very interesting, and I'm going to do that. So YZZ 1 operation. Can you find the conflict equivalent schedule? Conflict equivalent serial schedule using your. I'm not sure what this means, so I'm going to clarify it. So this one I'm not sure what does this mean. I should have. I mean, I can understand this one, but I'm not sure why this is that. So, verify this schedule below is conflict serializable using the preceding graph. So so this one, right? Oh, this one is going to let's see. Let's do that. Okay, let's do that. So we have two transactions, T1, T2. Any topological ordering is a conflict equivalent serial. Oh, I see. So as long as it's T, I mean, where is this 3 comes from? I'm not very sure. I can understand that any topological ordering is a but T1, T2, okay, and but we have T3. We have T3, right? So this is not right. So this is basically about the conflict equivalent serial, and we are going to talk about the transaction schedule in database management system. So the transaction manager, we have the continuous stream of transactions. It requires the operation from the transaction. The scheduler it executes or delays the request, and the conflict serializable schedule it offers buffers, and not enough to compute offline needs to be enforced. It requires it requires operation from transactions from the schedule, and the conflict serializable not enough to compute offline, needs to be enforced. This is not very sure, and let's go to enforcing the conflict serializability using locks. So let's talk about locks. A transaction has a lock. A transaction has to lock an atom before accessing it. A transaction has to lock an atom before accessing it. Just build an intuition. A transaction needs to lock an atom before executing it. Locks are requested from and granted by the scheduler. Each atom is locked at most one transaction at one time. Transactions wait until locks can be granted. So what does the granted mean? I'm not very sure. So each lock has to be released and locked eventually. So for example, we are going to lock an item X and read item X and unlock item X. The transaction 2, we are going to lock item X, read item X, and write item X and unlock it. So each atom is locked. Each item, I think each item, right, just like X is going to be locked at most one time. Transactions wait until a lock can be granted. Each lock has to be released eventually. So by at most one transaction, each lock has to be released eventually. So we lock item X, we read item X, and unlock item X. Okay. So I'm not very sure about what are the granted here mean. So let's check what are the granted here. I think I asked this question. Okay. What are the schedules with the simple locks? Extend syntax for schedules by two operations. The transaction I requires the lock, so lock for item X, and UIX is the transaction unlocks an item X. The example of the schedule is that we lock the item in transaction 1, and we read the item X in transaction 1. We unlock the item in transaction 1. We lock the X in transaction 2. We read the value in the transaction 2. We write the value in transaction 2, and we unlock the value in transaction 2, value X. So the rule here is for each RIX, WIX, there is an earlier IIX without any UIX occurring between IIX and RIX, WIX. For each IIX, there is a later UIX. If the IIX comes before IGX, then UIX occurs between the IIX and the IGX. I'm going to clarify it later, and I want to know more